This lesson covers the difference quotient. So we're going to talk about the difference quotient today. The difference quotient is one of the basic definitions in calculus, and it employs the ratio f of x plus h minus f of x divided by h. And of course we can see that h cannot be 0 because we know that we cannot divide by 0. So this ratio is what we call the difference quotient. And in calculus, sometimes you'll see the ratio instead of f of x plus h minus f of x over h, it'll actually be written as f of x plus delta x, that triangle is read delta, minus f of x divided by delta x. And we know that delta x, again, cannot be 0 because we can't divide by 0. And delta x just simply can be read change in x. So delta is just shortcut for change in. Now, we've seen something very similar to the difference quotient previously, and actually the difference quotient is actually derived from the average rate of change. Well, average rate of change, we of course know, is equal to the slope of the secant line. And the formula we use is y2 minus y1 divided by x2 minus x1. And so what we do is we have, let's assume we have some sort of a polynomial curve. I'll just make one up here. And I choose 2 points on this curve. Maybe my graph looks something like this. And I want to know the average rate of change between these 2 points. So this one I'll call this point I'll call x1, and this one I will call x2. And then, of course, we know that if I wanted the average rate of change, I can draw a line between these 2 points. That line, of course, is the secant line. In order to find the slope, of course, I'll need to know the y values. So the y value associated with x1 would be here. We'll call that y1. And the y value associated with x2 would be about here, and we'll call that y2. Then, of course, I can use those points. So I have x1, y1, which is this point here. And my other point is x2, y2, and I can use those in my formula to find the slope of the secant line. So that's all review. So keep these concepts in mind as we learn about the difference quotient, because the principles are exactly the same. We tweak this a little bit so that instead of finding the slope of the secant line, we're going to find the slope of what's called the tangent line. And in doing so, we modify the formula slightly, but the premise is the same, and the difference quotient is actually derived from the average rate of change. So back to our notes, when we're looking at the difference quotient, and we can see that it's f of x plus h minus f of x over h. What we've really decided here, or what we're really looking at here, is this. Again, I'll create some sort of a graph here. Okay, and I want to know between 2 points, I'm going to call this one x1, and then I'm going to call my other point here, let's say, we'll call this x2, okay? I've got this difference between x1 and x2, and we're going to call this difference h. So x2 is actually equal to x1 plus h. So let's change our notation here. So instead of x2, we're going to call this x1 plus h. Because whatever x1 is, add the value of h, that'll take me to that other value of x1 plus h. So if x1 is 2, h is 1, 2 plus 1 would take me to 3. If x1 is 5 and h is 100, then 5 plus 100 would take me to 105. Okay, so then I can find the corresponding points. Well, x1, the y value, is here is f of x1. Now, with the average rate of change, we refer to it as y1. They mean the same thing. And then for for x1 plus h, the y value is f of x1 plus h. So thinking back to our average rate of change, where we use y2 minus y1, well, if you think of f of x plus h as being your y2 value, and you think of f of x1 as y1, well, y2 minus y1 would, of course, equal this f of x plus h minus f of x, that's the difference in your y values, divided by h, where h would be equal to x1 minus x1 plus h. It's the difference between the x values. So that's where this formula comes from, the difference quotient. So I don't want you to think of it as being something entirely new or an entirely new concept. All it is really taking the average rate of change and adjusting the formula a little bit, because what we're looking at is just slightly different. And so what happens when we're dealing with the difference quotient, because at this point you're thinking, why do we use the difference quotient? Why don't we just use the average rate of change? Well, the difference quotient is used to find, let's see if I can create this again, the slope between 2 points on a line that are infinitely close to each other. So if this is x1, okay, and if h was very, very small, so as h approaches 0, so that x2 would be so close to x1, or x1 plus h would be so close to x1, that for all practical purposes, it lies on top. Okay, there's not really any difference. The difference between the 2 points is just so small. And so what we would do, if we were dealing with the secant, we would draw a line between 2 points and find the slope of that line. Well, what we do when we're dealing with the difference quotient is we still draw a line, find the slope of that line, but now we're finding the slope of what's called the tangent line. Okay, our tangent line is a line that touches the graph in only 1 point. So touches at 1 point on the graph. And we find the slope of that line. And what that line does, or what that slope represents, that slope will then represent the instantaneous rate of change. So at any given moment in time, what's the rate of change? It's the instantaneous rate of change at that particular point. Okay, so the average rate of change takes the average, takes all of the different slopes between those 2 points and averages them together. The instantaneous rate of change is at one given point, what would the slope be at that particular point? That's what we're finding when we calculate the difference quotient. Okay, so let's work some examples here. For our first problem, we're going to determine, we're given f of x is equal to 2x squared minus 3x plus 2, and we're supposed to determine f of x plus h. Now, what this means is everywhere within our equation that we have an x value, we're going to replace that x value with x plus h. No different than if this was f of 3, then you would replace, if this said f of 3, then everywhere there was an x, you would put in 3. Instead, we're just going to put in this expression x plus h. So f of x plus h will equal 2, and instead of x, I'm going to put x plus h squared minus 3 times x plus h plus 2. Now there's a lot of algebra involved with the difference quotient. So this is 2. X plus h squared can be written as x plus h times x plus h minus 3 times x plus h plus 2. So I've got two binomials. I need to multiply these together. So 2 times, so x times x plus h, we're going to FOIL this, becomes x squared plus xh plus xh plus h squared. I can distribute this negative 3. So this is negative 3x minus 3h plus 2. And then my next line, I need to distribute, well, I guess I'll combine like terms first. So 2 times x squared plus 2xh plus h squared minus 3x minus 3h plus 2. And then finally, I can distribute this 2 to 2x squared plus 4xh plus 4h, not 4, 2 h squared minus 3x minus 3h plus 2. That is my final answer. That is f of x plus h. Next, I want to determine what is f of x plus h minus f of x. And basically what this is doing, what this example is doing, a, b, and c, is taking the difference quotient and it's breaking it into manageable chunks, manageable pieces. Once you've practiced this a bit, you'll get to where you do this all at once. You won't break this into 3 different steps, a, b, and c. Okay, so what we found so far is f of x plus h, which is just simply the first part of the difference quotient. Up here, I'll show you what we're looking at here. So I'm just evaluating f of x plus h. That's all I'm doing here. Now, moving down, now I'm asked to find f of x plus h minus f of x. Well, we just found f of x plus h. That's what this is. Okay, so we don't need to do that over again. All you need to do is rewrite it. So that is 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2. And then now we're supposed to subtract f of x. So minus f of x. Well, f of x, of course, was my original equation from the top. So minus 2x squared minus 3x plus 2. Okay, be careful, watch your signs here. Make sure you use brackets or parentheses. Combine, well, let's distribute actually our negative through, and then we'll combine our like terms. So that will give me 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 2 minus 2x squared plus 3x minus 2. Now, after all that, I'm ready to combine like terms. So I'll tell you a little trick here. When you combine like terms, all of the terms on the far right are going to eliminate. Everything that you subtracted for f of x is going to eliminate. So start looking, I always start working from the right and work my way over. So negative 2, positive 2. Positive 3x, negative 3x. Negative 2x squared, positive 2x squared. So just go ahead and cross all those out. And that will leave me with a simplified version, which is 4xh plus 2h squared minus 3h. And that represents f of x plus h minus f of x, which is the numerator in the difference quotient. So at this point, I've still got one more step to go. Okay, so part C, determine the difference quotient. Well, if you look back up above, you'll see that the difference quotient is, of course, f of x plus h minus f of x divided by h. Well, what we just found in part B was f of x plus h minus f of x. So I can just replace them. I'm not going to do all that work over again. This is part B, okay? And so that becomes 4xh plus 2h squared minus 3h divided by h. Okay, I just need to simplify. So within the numerator, I have an h in each one of my terms, which means I can factor an h out. So h factored out of 4xh leaves me with 4x plus 2h squared, factor out an h, leaves me with 2h, minus 3h, factor out an h, is 3, divided by h. Now that I have h in the numerator and h in the denominator, I can see that these will cancel. And then that will be simplified 4x plus 2h minus 3. This is the difference quotient. So what this tells me is this: the instantaneous rate of change at any particular x point I want to put in here, and I can input what h is, what the difference is between the 2 points. This will give me the instantaneous rate of change, or the slope of the tangent line at that particular x value. Okay, page 2. We're supposed to determine the difference quotient of g of x, which is equal to 5x squared plus 3x minus 1. So this time, instead of breaking it into 3 parts, we're going to do this one all at once, okay? And jump right in. So the difference quotient, again, is equal to f of x plus h minus f of x divided by h. And this is a formula you'll need to know. You're going to have used it so many times, it's not going to be a problem. Okay, so let's start with the first part. So we want to know, even though it says f of x plus h, we can pretend, like this g is f of x. It's the same thing, just treat it the same. All right, so f of x plus h. Everywhere there's an x within this equation, we're going to replace it with x plus h. So f of x, whoops, ignore that. So everywhere there's an x, we're going to place it with x plus h. So we'll use 5, and instead of x, we're going to put in x plus h squared plus 3, and again, instead of x, we're going to put in x plus h minus 1. And all that does is I've just rewritten my function, my original function, 5x squared plus 3x minus 1, and everywhere there's an x, I replaced it with x plus h. Now, I'm going to subtract f of x. So be careful here. Use parentheses or brackets. When you subtract f of x, you're just subtracting your original function. So 5x squared plus 3x minus 1. Just written, it's just the original function. Just be careful and use parentheses. And then the whole thing is, of course, divided by h. So a lot of algebra here, so just work carefully and you should be okay. So 5 times x plus h squared is x plus h times x plus h. And that whole thing needs to be multiplied by 5. Plus 3 times x plus h. I can go ahead and distribute the 3 through. So I'll get 3x plus 3h minus 1. And then I need to distribute the negative through each of these terms. So that's negative 5x squared minus 3x plus 1. And again, don't forget, the entire thing is divided by h. Okay, we have a lot of simplification to do here. So 5 times x plus h times x plus h is x squared plus 2xh plus h squared plus 3x plus 3h minus 1 minus 5x squared minus 3x plus 1, the entire thing divided by h, okay? Next, we'll distribute our 5 through to each of these terms. So this becomes 5x squared plus 10xh plus 5h squared plus 3x plus 3h minus 1 minus 5x squared minus 3x plus 1, the entire quantity divided by h. Now, I'm ready to start eliminating some of these terms and combining like terms. So remember, I told you if you start from the far right, several of those terms will eliminate. Positive 1, negative 1. Negative 3x, positive 3x. Negative 5x squared, positive 5x squared. That should be at all of them. Now I can combine what's left. I'll have 10xh plus 5h squared plus 3h divided by h. This is much nicer. Okay, now from the numerator, I can see each term has an h. So I'm going to factor the h out of each of the terms. That'll leave me with 10x plus 5h plus 3 divided by h. Now that I have an h in the numerator and h in the denominator, I can see that those will cancel. And then my final answer will be 10x plus 5h plus 3. That is the difference quotient. So for any value of x that I want to put in there, any value of h for this particular function, 5x squared plus 3x minus 1, I can find the instantaneous rate of change at any particular x value. Okay, for the next one, g of x is equal to 1 divided by 5x. Now this one again is broken into 3 parts because there's some additional things going on here, so we're not going to lump it all together into one step like we did the earlier example. So first we're going to determine what is g of x plus h. So g of x plus h, everywhere there's an x, I'm just going to replace it with x plus h. 1 divided by 5 times x plus h. That's my answer. Part B, determine g of x plus h minus g of x. Well, we just found g of x plus h, so that is 1 divided by 5 times x plus h. And then now we need to subtract g of x. G of x is just my original function, so I'm subtracting 1 divided by 5x. Now, I need to combine this into one single expression. And I don't have a common denominator. So I'm going to have to find the least common denominator. So the least common denominator. In order to do that, I need to figure out what do they have in common and then determine what each part is missing. So for my first term, call it here, okay, my denominator, of course, is 5 times x plus h, okay? In my second term, yellow, my denominator is 5x. So I can see I already have the 5 taken care of. I have an x plus h, but that's not the same as x. So I'm going to take and I need to multiply by x as well, okay? This will, when I simplify this, will give me a least common denominator of 5x times x plus h. If I can come up with this common denominator for both of these terms, then that will allow me to combine the numerators, which is what I want to be able to do. Okay, so go back now that you know what the common denominator is, 5x times x plus h, and we're going to look at each of the terms and determine what they're missing. So 1 divided by 5 divided by x plus h already has the 5 and it has the x plus h. It does not have the x. So what I'm going to do is I'm going to multiply by the missing part. Okay, so I'm going to multiply by x divided by x. Now the reason I can do this is because it's the same as multiplying by 1, and I know that when I multiply by 1, I'm not changing anything. So when I multiply this out, I'll now have that common denominator of 5x times x plus h minus, okay, I have 1 over 5x. Well, I can see, let's move my marks here, I can see when I go through and I determine that I have the 5x here. I have this and I have this, but I don't have the x plus h. So what I'm going to do is I'm going to multiply by the missing piece, x plus h, divided by x plus h. Again, this is the same as multiplying by 1, so I'm not changing anything. I'm just changing, I'm just coming up with an equivalent expression. So now I can multiply my numerators here across, so I'll end up with x divided by 5x times x plus h minus 1 times x plus h, so that's x plus h, divided by 5x times x plus h. So now I can see I've got two terms, I have a common denominator, which means I can combine the numerators. So when I combine the numerators, I'll have x minus x plus h divided by the common denominator of 5x times x plus h. Okay, distribute the negative, so x minus h divided by 5x times x plus h. X minus x eliminates, and so we're left with negative h divided by 5x times x plus h. That is the value for g of x plus h minus g of x. So that's the numerator. And then finally, we're to find the difference quotient. Well, the difference quotient, again, is g of x plus h minus g of x divided by h. Well, in part B, we found the numerator. We're not going to do that again, okay? So we're just going to bring this down. This will be negative h divided by 5x divided by x plus h, and then the whole thing divided by h. Now remember, when we dealt with fractions previously, we talked about when you divide by a fraction, it's the same as multiplying by the reciprocal. So I can rewrite this as negative h divided by 5x times x plus h, and instead of dividing by h, I can multiply by its reciprocal. Well, the reciprocal of h, or h over 1, is 1 over h, okay? And then I can simplify those terms, so I can see I have an h in the numerator and an h in the denominator. Those will cancel. It'll leave me with negative 1 times 1 divided by 5x times x plus h, and that is my difference quotient. Okay, so the average rate of change in the difference quotient, we've already talked about this briefly. And of course, this asks us, do you see a relationship between the average rate of change and the difference quotient? And I would hope so, because again, the difference quotient, f of x plus h minus f of x divided by h, we know h cannot be 0, is simply the average rate of change through the points x, f of x, and x plus h, f of x plus h. And again, it's if I drew this graph, came up with something like this. I had a point here, I'll call this x1. I have a distance to the next point, which is h, which makes this point here x plus h, like this. And then the corresponding y values would be f of x and f of x plus h. And like we talked about previously, as h becomes very, very small, this point moves closer and closer and closer until it effectively sits on top of x. And then at that point, I'm finding the slope of the tangent line. Remember, the tangent line is just a point that touches the graph in one place, one point. And so when I find the slope of the tangent line, I'm finding the instantaneous rate of change between those 2 points. Okay. All right, our question says, given f of x equals 3x squared plus 4x, determine the average rate of change between x equals 1 and x equals 1 plus h, where they don't tell us what h is. We just know that h is not 0. It's some value. Could be large, could be small. We don't really know. So the first thing we're going to do is we need to evaluate when x is equal to 1, what's our corresponding y value? So f of 1 is equal to 3 times 1 squared plus 4 times 1. So 1 squared, of course, is 1 times 3 is 3 plus 4. So that is equal to 7. So my point, I have a point at 1, 7. We can think of that as our x1, y1 point if you want to. And then I need to find the second point, which would be at f of 1 plus h. So again, everywhere there's an x in my equation, I'm going to put in 1 plus h. So 3 times 1 plus h squared plus 4 times 1 plus h, do some algebra, 3 times, we'll have 1 plus h times 1 plus h, plus we can distribute this 4 plus 4h. So 3 times 1 plus h times 1 plus h, FOIL, you'll have 1 plus 2h plus h squared plus 4 plus 4h, and then finally we'll distribute our 3 to each of the terms, and so it'll be 3 plus 6h plus 3h squared plus 4 plus 4h, and then combine like terms. Let's see, 3 plus 4 is 7, plus 6h plus 4h is 10h plus 3h squared. So that'll give me, let's see, 7 plus 10h plus 3h squared. Okay, so the point associated with 1 plus h, and this is an x, y value, 1 plus h would be my x value, and then 7 plus 10h plus 3h squared is what you can think of as the y value. So again, it's driven based on h. It depends on how large h is as to what my y value is going to be. Okay, so if I'm looking for the average rate of change, we can use our formula, y2 minus y1 over x2 minus x1. So y2 minus y1 over our x2 minus x1. We'll say that y2 is going to be this value, 7 plus 10h plus 3h squared. We'll call that y2. And then we'll subtract y1. Let's see, y1 was 7. Okay. Divided by x2. x2 was 1 plus h. And we will subtract x1 up here, which is 1. Okay. Simplify, so 7 plus 10h plus 3h squared minus 7. My 7's, of course, will eliminate. I'm left with 10h plus 3h squared divided by, in the denominator, 1 plus h minus 1. The 1's will eliminate, h. Okay. Factor in h out of each of the terms in the numerator. It gives me h times 10 plus 3h divided by h. Now that I have an h in the numerator and denominator, those will cancel. And so my answer is 10 plus 3h. So using our formula for average rate of change, if I drew a line, a secant line between 2 points on the graph, from 1 to whatever 1 plus h is, depends on h, I will get an average rate of change of 10 plus 3h. Okay, now for the next part, they tell us to determine the difference quotient. Okay, so determine the difference quotient. So remember, the difference quotient is equal to f of x plus h minus f of x divided by h. So f of x plus h, back to my original function above, let's see, where'd my function go? My original function here is, that's up here, 3x squared plus 4x is my original function. And so f of x plus h would be 3. I don't want yellow. Okay, it would be 3 times x plus h squared plus 4 times x plus h. And then I'm going to subtract f of x. So minus my original function, 3x squared plus 4x. And the entire quantity, of course, is divided by h. Okay, do some algebra. We're going to simplify this. And so this will be equal to 3 times x plus h times x plus h plus, I'm going to distribute the 4x plus 4h minus, I'm going to distribute the negative, whoops, one too many. This will be minus 3x squared minus 4x divided by h. Okay. Keep simplifying. This becomes 3 times x plus h times x plus h is x squared plus 2xh plus h squared plus 4x plus 4h minus 3x squared minus 4x divided by h. Equals, so distribute the 3 to all of these terms, 3x squared plus 6xh plus 3h squared plus 4x plus 4h minus 3x squared minus 4x divided by h. Y'all are going to be really good at algebra by the time this is all over. All right, now again, working from the far right, let's look and see what eliminates. Negative 4x will eliminate with positive 4x. Negative 3x squared, positive 3x squared. That's it, nothing else. So that leaves me with 6xh plus 3h squared plus 4h divided by h. Again, you can factor an h out of each of the terms in the numerator. Now, if every term does not have an h, don't factor, because you have to be able to factor out of every single term. So h times 6x plus 3h plus 4 divided by h. Now I can see that my h's will eliminate, and so my final answer is 6x plus 3h plus 4. Now, I'm finding the difference quotient, but I also know that this difference quotient occurs at x is equal to 1. So I can evaluate the difference quotient when x is equal to 1. So when x is equal to 1, then 6 times 1 plus 3h plus 4 will equal 6 plus 3h plus 4, which of course equals 10 plus 3h. Well, guess what? Lo and behold, that is the same answer that we got in part A when we were asked to use the average rate of change to find the average rate of change between those 2 points when x was equal to 1 and x is equal to 1 plus h. So the point of this is this. You're doing effectively the same thing that you did with the average rate of change. We just treat it a little bit differently. We come up with an equation as opposed to just an answer. We come up with an equation that you can use then to find the average or to find the instantaneous rate of change at any x value on this graph. So if x was 2 or x was 7, x was 42, I can come up with an equation to find the instantaneous rate of change at those points. Okay, so as we've previously discussed, if I give you a graph and I give you 2 points on the line, and we'll call this, this first point here is our x, and then I give you a second point that's some distance away. We've been calling that distance h. Here they've called it x plus change in x. So you can think of change in x. That would be the same as change in x or delta x. They mean the same thing. So that distance away would then give me the other x value. And then, of course, I've got the associated y values. So this would be f of x plus the change in x, and then this would be f of x. So if I decrease that distance between those 2 points on that secant line, now this is a secant line because it intersects the graph in 2 points, but if I decrease that distance, so I move that point here, this blue one, okay, I move it closer and closer and closer until it's right next to, or basically sits on top of the red one, then what's happening then is that change in x, which of course is equal to h, is becoming close to 0, okay? And then after you simplify everything, then you get the slope of the tangent line at that point x. Remember, the tangent line intersects the graph in only one point. So if I was drawing a tangent line through x, it would look something like this because it would intersect at only the one given point. So as the 2 points on the secant line get closer and closer, we can see that the average rate of change approaches what we call the instantaneous rate of change, and that occurs at the point x and f of x. And the instantaneous rate of change, that's your next blank there, instantaneous rate of change is just simply the slope of the tangent line at that point x or f of x. Okay, so we know that the average rate of change is equal to the slope of the secant line, so between 2 points, okay, and it's the average between those 2 points, okay, whereas the slope of the tangent line will give us the instantaneous rate of change. So that's really the difference here between them. The average rate of change is between 2 points. We find the slope of the secant line, gives you an average of all those different slopes. The instantaneous rate of change is the slope of the tangent line through a single point on the graph. Okay, so now that you've made it through all of that, what I need you to do is this. You need to go do some practice. So in your lab manual, on page 62, I want you to do numbers 1, 2, 3, and 5. And after you do those in that order, then go back and try number 4. Number 4 is harder. That's the reason I'm having you do it afterwards. So go through, take a break, work on 1, 2, 3, and 5. See how you do, check your work. The key is posted, and then go back and try number 4 and see how you do on that one.